Hello.
Hello, Gopal sir. Welcome again.
Hello, sir.
Yeah,
Thank you so
good
much.
evening, everyone. Once again, welcome to your day two of the program. Right. So I believe you yesterday have learned a lot of things, and today you're going to continue from where we left off. So I'll take a moment before we start with the session to just invite you all guys to our meetup again. Right. So we're having it in the next weekend, Sunday. So I'm just going to show you a slide, and the link of registration will be also tagged. Just give me a sec. So if you guys are residing in Mumbai or Navi Mumbai or places near to Mumbai, who can travel to Andheri, which is the location Andheri, I'm just announcing Andheri. You can just go and you can say fill the form. It is an invite only event, so you will be shortlisted based on location and the proximity of your area, right? So just go and fill this form. So this is the banner. I'm just showing you to you all. So if you want, you can just sign up for the event and appear for the meetup. And this is the people who are living out of Mumbai or something. Do not worry, this is just the start. Mumbai is a prime location, like we operate out of Mumbai, so that's where we're doing it in Mumbai. So we'll come to Bangalore, Hyderabad, Chennai, Pune, all the places, right, one by one. So this is our first meetup. If you guys want to attend it, please go and sign up for the event. The registrations will close by Saturday, that is tomorrow night, and we'll start taking new registrations later. So please go and sign up for the event, and I'll see you on the day, right? So with that, I'll just stop here right here, and over to you, Gopal sir.
Thank you so much. Okay, hello everyone. Thank you so much for joining in and very good evening to all. So, how is it going? First, tell me, like, कैसे हो आप लोग? And meanwhile, let me share my screen with you guys. Hmm, share screen. Okay. Good evening. I'm from Jaipur, Rajasthan. Hello Shivam. Hello Srishti. Yeah, I'll gonna share that today. Don't worry about it. Okay, and this session will be an extended one. Like earlier, it was like yesterday, it was only for 1 hour. Today, it will be for 1.5 hours, approximately. Okay. All right. Okay. Okay. All right. All right. So I hope you guys can see my screen now. Can you? Can you or can you not? I think just let me again share this. No, you are not late. You're just on time. Yeah. Okay. Now it is visible, I guess. Uh, Now it is. Okay. Thank you. So now, if we go with this one. Like, okay. So where exactly we were, like we will be covering this case study here. Okay, like on this very session. But I think like we couldn't complete some of those plots here. So which we will now. And let's begin. Okay, so we saw what was the line plot, right? And we can also change the colors and everything. We saw all of it, right? But what about what if like how exactly we can plot out, like two plots on a same graph? So earlier what we were doing, like we were just having, like this. So what if I want to have a straight line along with a scatter plot? What if I want to have a parabola along with a straight line? How exactly I can do it, right? So well, basically, you can simply use this again. Like what exactly am I doing here? Like let me again like zoom in a bit. I guess like it might not be visible for you guys here. Okay, so right now what am I doing here? Like I'm just keeping the x value same, right? Like so I can have a similar range for my both y1 and y2, right? Like for the different axes and ranges, right? And here I am creating a data set xy1 and xy2, and I'm plotting it out simply. Okay, so if you see here, like for this one, like if you are aware of what exactly is your, like your this will be your 0 0, this will be your 0 1, this will be your 1 0, this will be your 1 1. Okay, and this is nothing but your array, right? Which contains a tuple, right? Like this is your tuple one and tuple two. And for that tuple one, like we have this, like what exactly we are saying, like, okay, go for the zeroth element here, or go for the zeroth index here. And in that index, like the elements index, like you can actually look for this x as well. Okay, so this is what we are plotting here, x, and we have here is y1, and then we have here x and y2. That's what we are doing here. Okay, and now for the x, y1, we are giving it a color of red and labeling it with the value of x1, y1, like from x1, y1 dot a. Okay, and we have got here the line style as this much. Like, like I want to have the line style as dashed and dotted both. Okay, like, so when I plot this out, you can see like, and for the second one, we are also plotting it out. Okay, so I missed yesterday's class. How can I get previous lecture? Just watch the recorded word, recorded video of the YouTube session. You will be good to go. All right, so when I do this, when I plot this out, you can see like we have got these two plots here. Like first one we have as the dashed one, this x2 and y2. Sorry, x and y2. It's not x2 and y2. Sorry, it's my bad. Right. And also we have here this dotted one here, right? So, okay, so like that is how you can actually plot it out. Like on a similar plot, on a same plot, you can plot out two graphs. So in this one, we are actually plotting out two lines here. The first one is the dotted one, and the second one is the dashed one. Okay, all right, moving on. So we have here line plot with the scatter plot as well. So you can also like right now what we were doing, like we actually plotted out two line plots, and this will be our scatter plot here. So for this one, I am just calling this plt.scatter method, and we are scattering this like all of these points here for this, and we also have this plt.plot, and we also have this like this line value here. Okay, so this line and this scatter, like which we are basically right now plotting it out like on the same graph. Okay, so that is how you can do it. Other than that, what else we can have here? We can also plot two plots on a same canvas but in a different frames. Okay, so right now what we are doing, like we'll be using a technique called subplotting in matplotlib. All right, so let me tell you like what exactly it is. So up until now, like especially for this certain part or for this certain segment, we have already seen this like quite a while, like quite a times. But what about the subplotting here though? Like what exactly we are doing? Okay, so matplotlib has a method called subplot, which basically generates canvases, like across rows and columns. So when I say 1 cross 2, what exactly does it mean? So basically, it means two canvases will be generated. Okay, so how exactly though? So we have here this row value here, and we have here this column value here. Okay, so we have got one row and two columns. So how exactly you can see like this will be our one row, and we have got here two columns. And this is your canvas one, and this is your canvas two. Okay, and for this one, like this is your number one, and this is your number two. So this part here is basically for number of your plot. Like this basically represents your number one plot, and this represents your number two plot. That's it. That's what it does. All right. Okay. Moving on. So like that is why I am putting here 1 to 1 and 1 to 2. Okay, and now we have this here. You can see like we got here like two plots here. So this is for first row and first column and second column. And this is your number one plot and this is your number two plot. Okay, all right. I hope like this is it clear. How to plot a curve line with different size of points. You can actually create a curve data point here. Like right now, what we are doing here, we are just like generating with simplistic like not a squared value, of course. So what you can do here, like you can follow along with curved like equation, like which is in this case could be y is equals to 4a x squared, right? So you just need to like you just need to create an x and you just need to square it. So what we are doing, instead of having a straight line or instead of having a one dimension, we are projecting that data onto a two-dimensional plane or onto a two like onto a non-linear projection. So that is how you can actually create it. Okay, bar charts vertical, and okay, so for this one, like The very first time we are seeing like this was your, like subplotting. What else you can have here is the bar charts or vertical plots. Okay. And bar charts, but in a vertical manner. We have got two bar charts here. The first one is the vertical one, and the second one we have here as a horizontal one. Okay, so this one is the vertical one. So let's say like I generate like I'm just having like this numpy array as A, B, C, D, E, and we actually have these like I'm just generating numbers between 1 to 50, 1 to 50, sorry, and like the range with like five values between 1 to 50. I'm just generating some random values here. So you can see like I am having these values A, B, C, D, E, and I'm just invoking this method called plt.bar along with X and Y. So here, if you notice, like on this case, this X, this X will gonna behave as a category, and this Y will gonna behave as a frequency for each category. All right. Okay. So if we see the like the last result, like there you go. You can see like here. Okay. So like for this one, this is your A, right? We have got here 9, 30, 28, 18, and 18, right? And this is your A, B, C, D, E. Okay. Right. Okay, and also definitely you can actually plot out a bar plot in a subplot manner as well, which I just did here. Okay, so right now instead of having 1 cross 2, I am having 2 cross 1. What does it mean? Like I am having 2 rows and 1 column only. That's it. Okay, and now we have this horizontal bar graph. Okay, and for this one, what we have here, let's say this, like I'm just calling this bar h method here. Like like this is your horizontal bar graph. Okay, and now like we have here this. Okay, so I'm just right now instead of having a vertical one, what we are plotting it out here like in a horizontal manner. That's it. Okay, all right. And then we have a stacked bar graph. Okay, like I hope like the horizontal and the like the vertical ones are clear to you, all of you. Okay, if not, just let me know in that case. Okay, and now we have got this stacked bar graph. So what do I mean by the stacked bar graph? So let's actually try to understand this here. Okay, so like let's say we have got like a few rectangles, and okay, so like let's say we have got here this orangish one. We also have this yellowish one. I just can't plot it out. Okay, let's actually have it as a white one. Okay, and in this case, I'm just gonna like divide this entire rectangle across 3 segments. This is your no, not in the white though. This is your like this is yellow. Okay, all right. And also like I can also put a like a sky blue here, like on the top, bottom of it. Okay. So now if you notice like this, what exactly we are creating here, like this can be referred as a bar one, this will be a bar two, and this will be a bar three. Okay. And in this case, for bar one is working as a bottom. And for bar three, bar two and bar one are working as a bottom. Okay, so what if somehow I actually plot the bar one first, and then by using the bar one as a bottom, I can plot out my bar graph just on top of it. Okay, so what we are doing here, like basically we are stacking it. Like basically what we are creating a stack of bar graphs, but in a vertical manner right now, which is by default behavior of this matplotlib library. Okay, so if I go here again, you can see the like what exactly we are doing, like I just explained. Okay, so like let's say I'm just taking an example here. Okay, like we have got 3 categories for medal distribution. Like the first one we have here as like the number of gold medals won by USA, then China, then Russia. Okay, so the gold medals won by Russia, sorry, won by USA is 20, and the bronze medal are 31, and the silvers are 41. Like the data can be skewed here. Like I just took an example. Okay, and the China, like right now, like maybe like in this example for sure. Okay, like won 10 gold medals. Okay, you can see like this is something I'm reading out loud. Okay, like this is for this is for like USA for gold, USA for bronze, and USA for silver. And this is for like China for gold, China for bronze, and China for silver. And this is for like Russia for gold, Russia for bronze, and Russia for silver. Okay, so these many values do we have here? Okay, and what exactly I want? I want to plot out my gold first, and then bronze, and then maybe like silver. Okay, like the first I should be having the gold as a stack, and then the bronze as a stack, which is using gold as a bottom, and then like the silver as a stack, which is using bronze and gold's combination as a bottom. Okay, so let's see how exactly we can basically like achieve this. So if I just basically like I just like calling this plt.bar method here. And what we have here is like we have got these categories here. So X, and we have got like gold values are here. Okay, like 20, 10, and 7. And we also have this plt.bar bronze, and we have got bottom as gold. And like now we are using this like parameter. So what exactly we are doing here? So I'm using like bottom as gold, which we just created here, and on top of it we are creating a bronze like bar, right? So we are stacking first the gold, and the just over it is bronze. Second we have here, the next we have here is silver. Okay, so all right, so you can see like we are actually using gold plus bronze as a silver. Okay, and when we see the results, when we see results here, okay, like let's see, we have got here results. So like you can see the gold one we have here as like as the bottom is like the at the most bottom part we have here, and this is what we have as bronze, and this is one we have as silver. Okay, so like for this bronze, like this gold is working as a bottom, and for this silver, this bronze and this silver is so this gold is working as a bottom, right? So okay, like it's everything is clear here. So that is how you can actually create a stacked bar graph. So the similar concept can be applied, but in a in a horizontal manner as well. Well, in this case, what we have here is plt.bar h. So x gold color y and label as equals to gold. plt.bar x bronze. Like you can see for yourself what exactly is going on here. Okay, and we have got here this left is equals to gold plus bronze, and color is equals to G, label as silver. Okay, and similar. Last, not the last. Okay, like okay, for this one it is last. What exactly your like the pie charts are here? So when we talk about pie charts, like let's say we have got this like circle here. Let's assume like we've got this circle, and now I want to like segment this circle across maybe like some of categories which might be able to like tell me about the analysis of a data. Let's say we have got three categories here: A, B, and C. Okay, and across A, B, and C, what exactly I want here, like like let's say we have got here this line here, not like this though. This is your first segment. Okay, this will be your second segment. Okay, like I believe I just like okay, like this is not first segment to second segment. I think I just segmented it across four segments. So I'm just calling it S1, S2, S3, and S4. So like it actually looks like a pie, like like it's an edible entity, like mostly famous in USA or like in Western countries, like like basically a pie which we eat, right? And what we do, we create wedges. Like this entirety will be referred as a wedge, right? Like you can also consider this as a cake, given that the cake is round, okay, like not a squared one. All right, so this will be a wedge, okay, and this wedge like you can like slice it over and you have that triangular shape over it. Okay, all right. Please give me a reply, sir. How to plot curve line with, okay, I just like this. I just explained. All right. Okay. Uh, all right. So now this is your this is your pie plot, or sometimes also referred as pie chart. Okay. So now let's begin. So now let's actually see the another. So now let's actually see the code of it. So we have got here this. Sorry. We have got this like uh, pie chart. We have got this here, and omelette ingredients we have here: egg, oil, spices, stove, and we have got this 35, 20, right? Like all these values. So what exactly is happening here in this case? This egg has a 35%. Like it basically occupies 35% of the entirety of your that pie chart, and this is 20%, and this is 15%, and this is 30%. So what exactly 35? Okay, is it summing up to 50? Yes, it is. Okay, sorry, 100. Yeah, it is. So if you see the contribution in a pie chart, which an egg has, like in this case, is 35%. Oil to make an omelette, like it's basically we are basically creating a pie chart based on ingredients, like what kind of how much contribution an ingredient will just gonna make when it comes to creating an or when it comes to making an omelette. Okay. And we have this 15% spices and 30%, if you don't have a heat, you cannot cook it for sure. And other than that, you have this percentage values as I explained here. So I'm just resizing the entire figure here with the help of 16 by 8. So it will be 16 pixels, in breadth, or I can just say in a width, and 8 pixel in height. So it will be row by column, like it is again how many rows do you have and how many columns do you have. So this is the size for your for your pie chart, for your entire graph. Sorry. So now you can see egg has the most egg made the most contribution here. And what if we can explore the wedges somehow? Now can you share the collab notebook here in the chat? I will. Okay. Before I'm gonna leave this session, I'm just gonna make sure I do that for sure. Okay. And then all right, I'm just gonna let you know. Just a sec. Okay. All right. Now is the how exactly you can even explore wedges, right? Like you can just use it by 0.2000. So right now, we are exploding the wedge by 35.2. So we are just taking a wedge out of it. So by 20% of it, and it's basically a value, right? Like how it actually varies from 0 to 1. So you can see exploding values. So we have got 4 values here, right? So therefore we need to give here how much explode, how much explode we actually wanna have a wedges. So here we actually do this. Okay, so we have this here, this plt.py, and percentage labels, omelette ingredient, and everything is there. And explode is equals to exploding values. So we have got this plt.title and omelette ingredients, plt.show. And when we do this, we've got this amazing looking graph. And you can also change the color. Like I'm just playing around with the attributes now. Like you can see the colors are here: yellow, gray, and red and black, and everything is there. And we also have this again, you can see, right? Like I'm just using the legend here, so I can also use the legend. So it basically shows this part egg, and this is the oil and spice and the stove. And also you can use the the percentage as well. So how much, in this case, this is actually 35%. So how exactly am I using it? By another parameter called AutoPCT here. Okay, and then there you go. All right, and we have this certain looking graph here. Okay, so that was your day one's day one's data visualization. Sorry for that. I couldn't complete it yesterday, but today the session will be all about 1.5 hours. We have extended the time, so I'll make sure I complete each of the topics which I have covered in terms of I can actually shed some light on at least on elementary data analysis and visualization. So if you have any questions like for the next 1 minute or two, so please feel free to ask those. Otherwise, I'll be starting off our next case study, which in this case will be Iris case study. So yeah, just let me know if you have any questions or not. Uh, okay, so let's start. All right. So if you like, I would like to actually open this case study first. Okay. Hmm. No questions? Let me have some water first. Okay, I don't think so. We do have any questions. Do you have any questions, guys? Let me know in the chat. No. Okay. So if you notice here, like what exactly this case study is all about, like I guess like maybe like in 1930 or 56 around, like I don't recall exactly the year, but it's quite a like older case study which basically like some botanist in those like times might have actually accumulated as a data and presented as a data analysis case study, but certainly we didn't have this much technology earlier, and we weren't able to distinguish between these three species that easily, which we can right now, like in this in 2022. All right, so giving this as a context, what exactly this all case study is all about, let's try to understand this first. So this in this case, like we have got three species here for different like flowers. Although if I just if I just put a somewhat like this, like let me just make it somewhat invisible. I hope I know I'm terrible at it, but right now I did my best here to make it invisible. Just do not right now, just for once, do not focus upon these words, or like do not focus upon these species here. All right, not at all. Okay, just forget about these names and just take a glance over these these pictures, only these pictures. All right. Can you tell just by taking just by taking a look on these pictures, like which one is versicolor, which one is setosa, and which one is virginica? Like certainly, like they literally look almost alike, right? Like we cannot make a distinguish, we cannot distinguish between these three species. Like it's really hard to make any kind of differentiation here. So how exactly we can determine this? Though we don't have we do not have a supervision or superhuman vision, certainly, but we do have a power of analysis here. What kind of analysis we will gonna perform? So let's see. So any data, any kind of data, like which has a numerical attribute to it, we can definitely perform linear algebra or some mathematical expressions over it, and we can gather some information around it. Okay, and which we will gonna do. So in this case study is all about sepal and petal. We have got we have got four features mainly here. And like in this case, this is your sepal and this is your petal. Like I still can't tell. Like, okay, I guess like sepal is something which has this yellowish thing on it, and petal is something like, like it's nothing but a petal, like which does not have a I don't know like what exactly the petal is, what exactly the sepal is. Okay, like I'm not a botanist for sure. So please excuse my ignorance and about the lack of knowledge about this sepal and petal thing. I'm just making a hunch here. Okay, what exactly they must have actually meant here? Like like this sepal must have been this yellowish part, and this petal must have been this without the yellowish part here. Okay, and we have got two attributes to each sepal and petal. What exactly those are? So in this case, we have got this, like this width and this length. Okay, we have this width. I'm just gonna refer this as a W, and this is your length. I'm just gonna refer this as an L. Okay. Okay, and similar cases for this one. Like this is your length and this is your width. Okay, does that make sense? Sense? Okay. So what we have here, sepal length, and what we have here as sepal length and sepal width, and also we have petal length and petal width. All right. So for these four features which we have here, F1, F2, F3, and F4, we have got these four features here. All right. And these four features will gonna determine. Okay, so if I like if I actually make you understand about like the way it should be, like the way you should actually understand this, let's say in our data formation, like the way it will be shown in the with the help of the pandas data frame, it will be as follows. So you will be having like a matrix, a data matrix, data set matrix. And usually, like in machine learning, we have two, like more than two, definitely, but we have two systems for learning. The first one is we have supervised machine learning system, and the second one we have here is unsupervised machine learning system. So in supervised machine learning system, you will be given dependent and independent variables. Basically, independent variables are those variables which are not dependent to one another. Okay, like they will be acting solely upon on themselves. Okay, so like if I make a data set matrix here, so you will be having this certain matrix here. Okay, and for this one we will be having F1, F2, F3, and F4. And for each sample, you will gonna have this Y here. Okay, so what do I mean by that? Like F1 is your sepal length, F2 here is your sepal width, F3 is your petal length, and F4 we have here as petal width. Okay, so let's say if I have here this 3.4, 5.6, 7.8, 9.1. I'm just making a totally a random, like you can see 3, 4, 5, 6, 7, 8, and 9, right? And 10, I would have actually wrote, written 10 here as well. So I'm just making a simple, like random data set here. Okay, and this certain data set will be referred as a, like a sample point. And if I constitute these four features, it will gonna form up a like it will gonna form up a species. Let's say this species is a setosa. Okay, so your Y here belongs to three species here. Okay, like three categorical values. The first one we have here is setosa. Second we have here as virginica, and the third one we have here as versicolor. Okay, and I'm just assuming like it's just a random number. I'm gonna explain like in a real data set. I'm just like taking a random value here. So if I put 3.4 as a sepal length, 4 point or then 5.6 as a like sepal width, and 7.8 as a petal length, and so on and so forth, I'm just gonna get my setosa here. All right, fair enough. Okay, so what now? Okay, so let's see. Okay, like let's see here for this one. Let's actually see for this one what exactly we are doing here. So again, I'm just using all these libraries which we just saw earlier. Like we saw matplotlib, we didn't see the seaborn though, which we will now, like in this case study for sure. And we also saw this numpy and pandas, and obviously this plotly was also there for interactive plots. All right. And now if I go back here and we have this like pd.read csv. So this read CSV, what exactly it is doing? Like it basically is a method for reading your comma separated value files. All right. So how exactly this file actually looks like? Let's see. Okay, like I'm just gonna open this file here. Okay, like you can see, like let me actually zoom in a bit. Okay, so now how exactly it is looking like? How exactly like you can see like these are your F1, F2, F3, F4, and this is your Y. All right. And like in this case, like we have got this 5.1 as a like sepal length, 3.5 as a sepal width, 1.4 as a petal length, and zero point 0.2 as a petal width. And we are forming up a setosa here. Okay. So if I put it as 5.1, 3.5, 1.4, and zero point 0.2, and it will be generating a setosa. And same case for this one, same case for this one. Like you can see all the entire data here. All right. Okay. And now, all right. I hope this is clear. Okay. And we have got how many data values we have here. So all these values are 150 data points. Okay. Across 5 columns. So this is your matrix here. 1, 2, 3, 4, 5. And like this is your F1, F2, F3, and F4. Like, and you can see like we will be having F1, F2, F3, F4, and Y. Okay, and for each one we have here 1, 2, 3, and 150 columns. Sorry, rows here. All right, so this is how like that is how we are forming a 150 by 5 here. Okay, is that clear? Does that make sense? Sense? Okay, I hope it does. Okay, so for this one, like let's say for this one, like we have got this df dot head here. Okay, and like this is for sepal length, sepal width, petal length, and petal width. So what exactly this head does firstly? So it like brings out 5 first rows from the data frame. Okay, so we have got this F 5.1, 3.5, 1.4, 0.2, and so on, like which we just saw, right? Okay, so this entirety can be expressed as a matrix as well. All right. Okay. Okay. And now if we go somewhat like here, and now as I explained, like I couldn't explain, sorry, right? So this is your F1, F2, F3, and F4. Like these are your features. Okay, like feature 1, feature 2, feature 3, and feature 4. So these will be referred as your independent variable. And this is your Y, which is your dependent variable, which is basically dependent on your independent variables. So like if you do not have these variables, certainly you will not be able to decide like which species is which, right? It is the only logical inference here, right? So therefore, we need these independent variables in order to create another entity, which basically will gonna depend upon these independent variables in the end, right? And now if I go back here, okay, and now we have this like independent variable and dependent variable df.info. And let's start off with this method, like like df.info, what exactly it is telling us. So for this one, we have got like 4 values here. The very first value which we have, sorry, 5 values. So this is for sepal length, and this is for sepal width, and this is for petal length, and this is for petal width. Okay, and if you notice, like the data type for all these columns is float 64. So what exactly a float 64 is, like basically which actually belongs to your R or a real number, right? A real number is what? Like, like which actually belongs to minus infinite to plus infinite. This is your floating value. Like, like not this though, not float, like this floating value, right? And this is your object. What exactly is your object though? This is your categorical value. Categorical value basically means you have got a few categories to deal with. Right now we have got 3 categories mainly, like eventually the Setosa, versicolor, and Virginica. I hope this makes sense. Okay, so this is something your data like df.info is telling you all about. But what exactly your 150 non-null values, like what exactly does it mean though? Like this certain part. So it basically means like 150 non-missing data. which is not null in this case. All right. Okay. So this is for non-missing and this is for data type. So basically, this is our df.info is telling you all about right now. Okay. So I guess like for this one, we have here this. And when we do this, like df.describe, what exactly we have here? Like this describe method only works on numerical values. Okay. And we have here this sepal length, and we again sepal width, petal length, and petal width. So for this one, we have the column for 150, 150, 150, and 150. So the mean or the average value, like what exactly, like let's actually focus upon this certain column first. Only for this column. We will gonna focus upon only for this column here. Okay. And for this one, like this is for the count, like how many values do I have in my sepal length column? So the answer here is you like 150. And what is the average value in that column? Like it is 5.84 centimeters. And by what value my average value is deviating from? It might be somewhat trickier at first. So if I see the standard deviation, like this is my average value, like my mean is basically your average value, right? This is your average here. And what exactly this is your standard deviation. Your standard deviation is basically tells you like by what value your mean is deviating from, either from plus side or either from minus side. So if I make this like your average value can deviate like this 5.84 plus minus 0.84. Like I'm just taking an approximation here. Like this value can be approximated to 0.84. Like I know it will be 0.83, but let's actually take a lump sum of it like 0.84. Right, like so 5.84 minus 0.84 will be 5 centimeters, and 5.84 like it will be around how much it will be 6 point something something. Okay. All right, and the minimum value for this we have here in the sepal length we have here as 4.3 centimeters. And for this one, like for this one, we have got this 25 percentile. Like this value is percentile value. It is not percentage, but percentile. Just remember this. Okay. So if I try to make a statement out of it, 25 percentile of 5.1 centimeter, what exactly does it mean? So it basically means like let's say we arranged all of our sepal lengths across a line, like horizontal line, which basically divides your 0 to 100% values like this. Okay. And now this 25%, like this is your 25th percentile value. This will be your 50th and this will be your 75th. Okay. And this 25th percentile value will be put at like somewhere around here, 5.1 centimeter. Okay. So now how exactly? So whatever the values you will gonna have here, whatever the values you will gonna have here, we're gonna have we're gonna have a sepal length less than 5.1 centimeter. So what the value is for what 25%, right? So how exactly I can like basically I can write it in plain English. So I can just simply write it as like no 25% of my sepal lengths, like we're gonna have we're gonna have less than 5.1 centimeter. Like okay, less than 5.1 centimeter. Does that make sense? Yes or no? Just let me know. Like if it is clear to you or not. Similarly, I can make a statement here for 50th percentile too, 5.8 centimeter here. Like in this case, 50% of my sepal length will gonna have a sepal length less than will be less than 5.8 centimeter here. And similarly for 75th percentile value, we have 6.4. Okay, all right. So if I go back here, we have this like df of species dot value counts. So you can see like we have got this versicolor, virginica, and setosa. Okay, so for this one, like I hope like this is clear. Okay, and maximum value which we have here is 7.9 centimeter. And now let's actually talk about this certain like uh, data here. So for this one, we have like species. And in pandas data frame, we have a method called value count. So what it does, like it takes each categorical value and counts its frequency. Like in this case, we have got 50 versicolor, 50 virginica, and 50 setosas. So like it's perfectly balanced data set. Sorry for my handwriting. Okay, I think. I think I cannot see your chats. Just a sec. Okay. All right. Yeah. So in this case, this is your perfectly balanced data set. All right. So let me actually get comfortable. Yeah. Okay. So now, if I go with this one, like what if I actually, like again, I told you earlier what, like your pandas is actually an underrated tool for plotting. Like it's an extremely useful tool when it comes to data visualization. Okay, all right. So now, if I make a new page here and convert it to cursor, like you can see, like we've got a perfectly balanced stack, sorry, not stack, but a bar graph here. Versicolor and Virginica and Setosa species are all on same level. All right, okay, and we have got this scatter plot here, 2D and 3D. Okay, and now you can also plot out a 2D and 3D scatter plot. So right now, but it is not making any sense. Like, although what we are doing here, like we are extracting all sepal length and sepal width values here. Okay, and for this one, we are just like scattering those values over X and Y plane, right? Okay, and then we have PAT dot title, X label, and Y label. All right, and for this one, what we have here is like but it is like earlier like what we had the problem with that x1 y1 like x2 y2 where we actually provided the label, so we need to provide labels here as well. Okay, so what exactly am I doing here? So now let's focus upon here, guys. Okay, just focus here now. So here in this case, like in this case, I'm extracting sepal length values. Okay, so in this case I'm just taking the species as sepal length. Okay, and where we have as a versicolor. Okay. Similarly, I'm taking the sepal width as a species as a versicolor. And we have this sepal length as a species as virginica and sepal width as a species as as virginica again. So I'm just extracting each of those values like one by one. Okay. And now in the end, I'm plotting all those points which we just saw, right? Like how exactly you can plot out different or like different plots on a similar graph. So we have got this like PRT dot scatter and Virginica, sepal length, Virginica, and I'm just giving it a label, Virginica and marker, and I actually gave here, like three different markers. So now it is making somewhat more sense. But there is a problem though. How many of you can tell me like which one, like which data or which or like like which data points are mostly overlapping here? Like if you notice here, like for this one, like this certain region is mostly overlapped, like for Virginica and versicolor. So whenever there is an overlap, just like it's quite axiomatic, but I'm just putting it out there. Like whenever the data is overlapped a lot, so all those data points proximity is somewhat nearer to one another. Like they have similar values almost. So if I see like this value, like for this one, like this is exactly like if you notice like for this one, the sepal length, okay, and sepal width for this certain point is exactly same for versicolor and virginica. exactly same, right? Like they literally are overlapping on one another, right? Okay. So now, if I like, so we can or also you can also notice here, like Setosa is easily distinguishable, but Virginica and Versicolor seems to having so much overlap. And whenever I see something here, I basically write it down. That is what your observation is all about. That is what your analysis and converting that analysis to an observation should be all about, right? Like that is why you do data analysis and visualization. So you can gather information about the data, what exactly is going on, right? And for any predictive analytics or for any predictive modeling, which you might encounter in the future, like in your, like in your career, as a data scientist or as a machine learning engineer, right? You will gonna perform a lot of data analysis. And believe me or not, like 90% of the times you'll be dealing with the data cleaning, exploring it out, like what exactly it is saying. And 10% of the times you'll be just doing that training part and tweaking it and performing those hyperparameter tuning operations to make it much more better and smoother. But if your data is not, like in a well-suited format for your model to train on, like there's a saying in the machine learning, like realm, like garbage in, garbage out, right? Like if you feed your model, if you feed your model garbage, it will just gonna like output the garbage as well, right? So by improving the data quality, you will also gonna improve or and enhance the predictive models quality as well. So focus upon analysis, focus upon how exactly you can improve the data quality as well. By like there are several techniques. First, which is the foremost is here in this case is data analysis and visualization. Basically, visualization is nothing but it has more to do with the whatever you have analyzed so far. You basically put that analysis on a plot. That's it. All right. And now uh, so like I like actually made a quite an effort here in order to like have it this way, but certainly you don't really have to do it right now. What we will gonna do, like we'll be just using this cbond library, which is in this case like sns.facet grid, and we have got this data frame again which we just saw, and we have here this like hue as a species. So hue as species or hue is equals to species is working as a legend or a label for each category out there. Like for not out there, but for this Setosa, versicolor, and virginica, right? And how exactly it is working though? So let's try to understand this as well. So this SNS dot facet grid will just gonna create an empty canvas. Okay, this empty canvas just will just gonna look like this. Nothing like we don't have any plot on this canvas just yet, and we have got this data frame on this like on this canvas, and we are taking a column like in this data frame we have a column called species, and this height is the height of this like y-axis basically. So I'm taking it as a 4 pixel, like whatever the pixel value or unit it might be taking right now. And now what I want to do, since we have this data here, right? Since we have this data here, I want to project this data onto a scatter plot. So therefore, what exactly am I using here? Plt.scatter by using two features here, sepal length and sepal width. And the moment I do that, there you go. You have your amazingly looking plot here, sepal length and sepal width for species, Setosa and versicolor. Sorry, species, sepal length and sepal width. I just sometimes just read it out loud. All right. Okay. So is that clear to you or not? Just let me know. Like to every one of you, any questions? Oh, why did I do that? Why did I do that? No, 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 no. Stop. Okay, it will just gonna generate an error because we have not imported anything yet. Okay, so I'm just gonna cancel it out. The moment it will just gonna look. Okay, there you go. I think I need to like run this from the very beginning here. Let me run this. And not from here though. From here, 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 from here. There you go. Okay, guys, please don't be here for just for the sake of the attendance and for the certifications. I'm being honest here right now. If you are coming here just for the certifications, like then you might want to look at your priorities, your learning priorities for sure. Okay. If you're just here for the certifications, that is not, you can actually make the best out of it. The way you can make the best out of it, the kind of questions that you might have, right? So please have your questions as many as you can. I would be humbled. I would be glad to answer all of your questions, and also, like, I actually take questions as a fun exercise for myself as well, because it also helps me in learning in a better dimension, right? So please ask as many questions as you can. Uh, can you explain again in short story what kind of short story you want to hear? Like, please explain Raj Krishnan Mahajan. I don't know what exactly you are talking about. Okay, so right now, what exactly am I using here? Like, this is your 3D scatter plot, which you might be seeing for the very first time. Okay, and again, like, I'm using this with the Plotly library, which is an interactive plotting library, like, plot library. So in this case, if I just zoom out a bit, okay, and I'm just gonna zoom out a bit, and also we're just gonna, like, rotate it over somewhat like this. So right now, like, we got here three values here, right? Okay, so for this one, we have got here, like, three values here. So for okay. So for these three values, we have, like, the Virginica, Versicolor, and Setosa, right? And this time, like, this is actually looking pretty good, right? And based on what? Like, for this pattern length, if I actually go for this axis, if I go for this axis, right? For pattern length, it is actually looking good. Like, there might be, like, there is overlap, there is still an overlap, but the overlap is not that huge when we actually were using sepal length and sepal width. So you can literally see here, pattern length is a better feature, like or a more suitable feature when it comes to distinguishing between these three species, Setosa, Versicolor, and Virginica. All right, and if I just, like, rotate it over somewhat like this, maybe. Uh, my bad. Okay. This always, like, drives me crazy. So sorry for that. Oh, what the hell? Sorry for my language again. Orbit rotation. Okay, this is much better. So, like, let's say, like, like, this is for petal length. Okay, I'm taking two features here, petal length and petal width. But if I take sepal length, okay, just actually focus upon here, like, like, on this axis only. Okay, on this axis only. Like, now I'm taking sepal length and try to, like, like, from your eye, like, from your eye, try to only look into this direction now, like, like a 3D direction. And now again, this is, like, messed up. This is totally messed up. But the moment I turn it over, right? The moment I turn it over, like, for maybe, for, let's say, for, like, just a sec. Okay. The moment I turn it over, maybe, like, for petal length, right? Like, it is much better. And even for petal width, I know, like, you must be having some hallucinations right now. Okay. But trust me, this is not my intention. Okay. But for petal width, but for petal width, it will be much better. Okay. Like, you can do it on your own time. Like, I will be just sharing this notebook with you. Okay. All right. So yeah. So now what we can see here, like, this is the observation which I just made. Okay. So the moment I added the petal length, we can now determine which group of petal length and sepal width belongs to specific iris species. But right now, whatever we have covered so far, like, it was in the realm of three or two-dimensional spaces. But when I say machine learning is just not limited to two or three dimensional spaces, but to million dimensional spaces, like, literally, you can have million dimensions in a machine learning project, or like in a machine learning data set. And, like, to just like, project, like, shed some light over it, each feature will be considered as a dimension. All right. So when I say we have got, like, four features, so we can also say in machine learning realm, or in the domain of machine learning or data science, we have got four-dimensional data when we have four features. Okay. So what if we have, like, right now we have got only three dimensions, but what if we have A, B, C, D? Like, in this case, like, we have got four dimensions here. So how exactly we can tackle this certain problem? So there is a technique called pair plot. Okay, what exactly the pair plot is all about? So basically, we take pairs and we plot scatter plot all over it. Not specifically, you can also definitely use different plots as well. But right now, let's actually talk about only pair plots in the domain of scattering all over the data over XY plane, all the data over XY plane. Okay, so what if we take combinations of these features as in pairs and we act upon it as a scatter plot? So what if I take A and B and create a scatter plot? What if I take A and C and create a scatter plot? What if I take A and D and create a scatter plot? Similarly, B and C, B and D, C and D, right? And like in this case, if you notice, like what exactly we are doing here, you're right. We are choosing two elements. We are choosing two elements out of four elements. Out of four elements, right? So how many of you can tell me like the permutation for this one, like permutation and combination? So this problem actually belongs to combinatorics. Like so, in how many ways? Like if I rephrase this question, in how many ways? In how many ways? In how many ways I can make combinations of two elements, basically a pair, out of n elements? What is the answer? How many of you can tell me the answer here? Like let's actually pause for a while, like for maybe like for a minute, because I know like this actually delays for a while. So just answer this. Like how many of you can answer it? Just take your time and let me know what exactly the answer will be. Well, someone is saying 12. Interesting. By the way, answer 12 is totally correct for four features there, A, B, C, and D. Shreya is saying 6, 6, 6. All right, everyone is saying 6. But like right now we have four elements. I'm talking about here about like n elements. N elements, yeah? Like let's actually not limit ourselves to only four elements. Let's talk about n elements. So this problem is like the correct answer here is 12. If you have seen this, like if you have literally opened your third eye and you literally went for that one, I like kudos to you, Raj Krishnan Mahajan. The answer is spot on, is 12. Okay, but the total unique combination which we can make is 6 only. Okay, so we have got two answers here. The very first one we have here, the total combinations with the replicas of A, B, and B and A, we can make 12. But the total number of unique, like combinations, we can only make 6 here. Okay, so for n elements, what we can say, like, what if I say NC2? This is the best we can actually go for, right? Like what we are saying here, like we are picking out two values out of n values. This is your NC2. And this NC2 can also be expressed as n minus 1 divided by 2, right? Like you can calculate it with the factorial and everything, right? Okay. So now if I put the 4C2 here, it will be 4 divided by 2 multiplied by 2 divided by uh okay, like 4 divided by 2, okay, and 3 divided by 1. So it will be 6. So we can create 6 unique pairs. But A, B, C, and D. We can actually create 6 unique pairs, right? A, B, A, C, and A, D, B, C, and B, D, and C, D, right? Like we have got 6 pairs here. But what if we can also create a replica of each pair? B, A, C, A, D, A, C, B, D, B, and D, C. This is the replica. Okay, so therefore we have got six unique combinations of those values, and also six replicas of those. So total number we will gonna plot here is the 12. Because यार ये भी तो possibility हो सकती है like okay, sorry, I actually started out in Hindi because there could be a possibility as well for AB to replicate on BNA as well. We can literally switch axes as well, right? Like we can make a plot on X and Y and Y and X both. Like there is no issue with that, right? So let me actually bring you back to the case study again. And this is something we are doing here. Okay. So right now, how many plots do we have? Like how many features do we have? Four features: sepal length, sepal width, petals, and petal width. Okay. And you got that right, right? Like the number of features we will gonna sorry, the number of pair plots we will gonna have here in this case will be 12. But along with those 12 plots, we will also gonna have a uni-weighted plot as well. Okay. So univariate, like what exactly, like this is the very, like suitable time for me to introduce you, like what exactly your univariate analysis is and bivariate analysis is. So your univariate analysis falls for when we, when we gather info about single feature. And your bivariate is when we perform analysis on two features, basically, right? Two features here. Okay, does that make sense? I hope it does. Okay, so for univariate analysis, in this case, I will gonna explain maybe like tomorrow on univariate analysis for each for those all like single features like F1, F2, F3, and F4. We will gonna perform a method called like normal distribution plot, or to put it more specifically, a bell curve. We will gonna see. Okay, but in tomorrow's session. So we will in total we will gonna have 16 plots here. So let's actually talk about these plots here. Okay, and now I'm just gonna like open this in a new tab here, somewhere around here, and I'm just gonna zoom. Okay, zoom in a bit. Okay, so for this one we have got here this. Okay, so for this one, like I know like it might not be able to see it here. I'm just gonna this is what exactly it is written. This is your sepal length. I'm just writing it as SL. This is your sepal length, and this is your petal width. I'm just writing it as PW. I know like you might not be able to you may not be able to see this here. I even I can't right. So this is a totally understandable. So for this one, like for sepal length, if I zoom in a bit, if I zoom in a bit, okay, like this is let me actually zoom in more. And now I guess like it is much more visible, right? Okay. So for this one, we have got two features here, the petal width and sepal length. Okay. And for these two features, we have got if we go like we have got two options. If we go horizontally, we can go horizontally and we can also go vertically. Okay, let's actually go horizontally and see like based on sepal length. Basically, it's on x-axis, so we will gonna go horizontally. So when we go horizontally, you can see like again like there is extreme overlap. Like we cannot make any sense. Again, like with the help of sepal length, we cannot make any sense. Like which species is which. But when we go vertically, like like in this manner, like this is distinguishable easily. This is also distinguishable by having a few errors here and here, like literally not so much overlap, like not so much overlap, a minor overlap here. But with the help of petal fit, we are able to distinguish features like in a better way. Okay, and with the sepal length, like it's a totally a disaster. You cannot make any sense out of it. Can you? You cannot. Okay. Secondly, like okay, let's actually talk about this again. Like the second, like this was your very first like graph here. The second one we have here is this one. So for the sepal width, what we have like again, like what earlier we had sepal length, and we have got here sepal width now. Again, like let's actually go the horizontal and the vertical manner. So if you go horizontally again, this is again like oh, sorry. I think I am I think I am saying it in a inverse manner, right? Like but it is actually vertically when we talk about an horizontal component. Okay, so it is actually vertical. Okay, so let's actually go vertically. Like let's actually segment this entire graph vertically for your horizontal component. Okay, so again, like there is extreme overlap again. Let me have some water. Excuse me. Okay, there is extreme overlap here, and then again, like we have also have here, like extreme overlap. But the moment I go again, like for my on horizontally here for my vertical component, it again, like is again good. So your sepal length and sepal width is a disaster when it comes to determining which species is which. But your petal width is certainly is a blessing for your data set. Like literally you can determine just with the help of petal width, like okay, like this actually belongs to like certain species in a better way or in a more intuitive way. All right. And now if I go back here, okay. You also like which we saw like the petal width. Okay, and now we have also petal length. Okay, so on the just focus here. Okay, so like we have got petal width on the y-axis. So I'm just gonna put it here as like or for this one we have here. This is your petal width, and this actually looks beautiful. How so? Even if you go vertically for your vertical component for petal width, the data is quite separable. And even if you go horizontally, the data is still separable. Okay, so you can see like even if we went like vertical and horizontally, the data is quite separable. So how exactly what exactly we can say here? What exactly we can say here? So based on this certain data, like based on this certain data, the feature importance. If we talk about feature importance for determining species, I can say petal petal width is much better than petal length, and this is much better than sepal width, and much better than sepal length. Like these two are disaster. Like petal width and petal length is almost like like on a same scale. Okay, but these two are totally a disaster when it comes to determining a species. All right, and like you can literally determine is like satosa flower. Like if you notice here, this is your satosa, like which we just saw. Like the satosa was the most isolated one. Like this is your satosa. Okay, and for this satosa we have got this like pattern length here. So we have got this and we have got this, and we also got like this is your petal width. So like if you notice here, like if I can literally create an if else block here. Like if I say if petal length is greater than sorry, if petal length is greater than 1 centimeter and petal length is like less than 2 centimeter, my species is Setosa. That that much powerful it is. And similarly for petal width is like if I go with the petal, I don't know like what exactly the scale is here. So I guess like it was 0.1. I don't know the scale here exactly. Sorry for my ignorance here. But let's actually take for like let's actually take right. This is for 0.5 and this is for 0.1. I'm just taking a guess here. So again, I can literally write a like if else block and I can make a distinguishment here. Like like this certain species actually belongs to Setosa species with the simple if and else block. That's it. Like that much powerful your petal width and petal length features are. Okay, so that is the power of your pair plot, and we will gonna understand about these distribution plots, but in our tomorrow's session. So that is it for today, guys. If you have any questions, then please ask. Do not hesitate to put your questions in chat box. I will be like I would be glad to answer those. And yeah, I'm waiting for the responses. Yeah, please answer. Please ask your questions, guys. Please. Any questions? Read सीधी कर दो यार. Any questions, guys? We actually did on the same axis. We did, I guess, right? We so to answer your question, Shreya, yes, we can. If you want to create a line graph and a bar graph for the same data, yeah, it is possible. Definitely, it is possible. Okay, so meanwhile, I'm here. What I can do here, I can just go to the YouTube, right? I can, and then I can put the link here. Hello, moderator. Can you please pin these two notebooks for our students? These two, if you can. Otherwise, I'm just gonna put it in the chat, like after this session. All right, guys. So since we don't have any questions, okay, thank you so much, Vishal. Okay, I guess like it was for the day two. Oh, no, okay, day one, and it will be for day two will be this much. This will be, and Vishal, please put this one as well. Thank you. So can you create some correlation on the same axis? Yes, we can. We definitely can. Like it will be a simplistic Pearson correlation, right? Like we can where we can actually determine the variance, like how exactly the variance actually like changes based on one feature to the another one. So yeah, to answer your question, definitely we can. Thanks for the session. Thank you so much for joining in, Rishikesh. Rishikesh Singh. Okay. Thank you so much for joining in. All right, guys. Any questions? Any questions? Any questions? All right. I don't think we have any questions now. So thank you so much for joining in. And bye bye. I'll see you tomorrow. I'll see you this time. Till then, please take care. Bye bye. Okay. Good night. Thank you.